Hello, in this video we are going to discuss about series and parallel circuits. To put it simply, series circuit is where the current has only one path to flow within the circuit and parallel circuit has the current to flow through two or more paths. By the way, I am explaining the circuits in conventional current flow. The conventional current flow is where even though the current actually flows from negative terminal to positive terminal of the supply, we need to assume the current flow is from positive terminal to negative terminal. Why? Well, I will make another separate video to explain about conventional current flow. But for now, let's stick to the conventional current flow in this video. Now, if we go into details about series circuit, all the elements are arranged in single path. Current flow through one component must flow through all the components because there is only one path for the current to flow. Now, let's go for an example. As three resistors connected in the series in the circuit, then the total voltage is divided or shared among the three resistors. It means in series circuit, the current is same at any point in the circuit and the voltage is different at individual components. So to get the value of total voltage, we just need to sum up the individual voltages in series circuit. So to get the total voltage, measure the voltages at individual resistors. So let's call the left side resistor as R1, middle resistor as R2, and right side resistor as R3. And if we measure voltage at R1 is V1, voltage at R2 is V2, and voltage at R3 is V3, then total voltage V total is equal to V1 plus V2 plus V3, and the current is same at any point in the series circuit. So the current is also same at any resistor in the circuit. So if the current at R1 is I1, at R2 is I2, and at R3 is I3, then the total current is I total is equal to I1 is equal to I2 is equal to I3. And the total resistance in the series circuit is sum of all individual resistances. So R total is equal to R1 plus R2 plus R3. Now, if we include the values, let's say current is 3 amperes and resistances R1 is 2 ohms, R2 is 2 ohms, and R3 is 1 ohm in the resistors. Now, let's find out voltage at individual resistors. So, by using Ohm's law, V is equal to IR, or voltage is equal to current times resistance. Voltage at resistance R1 is V1 is equal to I1 R1. Since the current is same everywhere in the circuit, let's call I1 as I. So V1 is equal to IR1. Then V1 is equal to 3 into 2, which becomes 6 volts. So voltage at resistance R1 is 6 volts. And voltage at resistance R2 is V2 is equal to I2 R2. Again, current is same at anywhere in the circuit. So V2 is equal to I R2. Then V2 is equal to 3 into 2, which becomes V2 is equal to 6 volts. So voltage at resistance R2 is 6 volts. And voltage at resistance R3 is V3 is equal to I3 R3. Current is same everywhere in the circuit. So V3 is equal to I R3. Then V3 is equal to 3 into 1, which becomes 3 volts. So voltage at resistance R3 is 3 volts. Now, by summing up all the individual voltages, we can get the total voltage. So, V total is equal to V1 plus V2 plus V3, which becomes 6 plus 6 plus 3 is equal to 15 volts. So, total voltage among the circuit is 15 volts. Let's again calculate the voltage using the Ohm's law, but this time by using overall values. Realize that we have calculated the voltages at individual resistances using individual currents and individual resistance values, and summed up all the individual voltages to get total or overall voltage. But now let's calculate the overall voltage with the values of overall current and overall resistance. So V is equal to IR. Since current is equal everywhere in the circuit, we already have the value of overall or total current, which is 3 amperes or amps. And to get total resistance, we need to sum up all the individual resistances. So R total is equal to R1 plus R2 plus R3, which is 2 plus 2 plus 1. So total or overall resistance R total is equal to 5 ohms. Now we have got the total values of current and resistance. Let's substitute them in Ohm's law. V is equal to IR. Then V total is equal to 3 into 5. So V total is equal to 15 volts, which is same as when we calculated after getting individual voltages. I have shown three resistors in circuit just for example purposes. There can be more number of resistors or any other components can be connected in the circuit according to need or desire. Now, the advantage of series circuit is simple in design. All the components can be arranged in series where current flow is equal at any point in circuit. But the main disadvantage of series circuit is if one component is turned off or failed, then the circuit becomes open, current flow stops, and the other components are also turned off. An example could be decorating lights we use while celebrating any events. They are connected in series. To give a bit conclusion about series circuit, the current is same and voltage is different in them. I will give you a tip to remember the current is same and voltage is different in series circuit. Look at the word series SERIES. It has letter I which indicates current and current is same in series circuit. So by that we can always remember current is same and voltage is different. Now about parallel circuits. All the two or more elements or components are directly connected to the same voltage source. By this way, current has multiple paths to flow, then each element or component operates independently of the others. Example, three resistors are connected in parallel in a circuit, then the voltage at any resistor is same as the supply voltage. So the voltage is same between any 2 points in the circuit when measured parallelly. So the voltage is also same at any resistor. So let's call left side resistor as R1, middle resistor as R2, and right side resistor as R3. So if the voltage at resistor R1 is V1, at resistor R2 is V2, and at resistor R3 is V3, then the total voltage V total is equal to V1 is equal to V2 is equal to V3. And the current is different at individual resistors because now there are multiple paths to flow, so current is shared among different components which are resistors here. So if current at resistor R1 is I1, current at resistor R2 is I2, and current at resistor R3 is I3, then the total current is sum of all individual currents. So I total is equal to I1 plus I2 plus I3. And the resistance in parallel circuit is the inverse of total resistance equal to the sum of the inverse of each individual resistances. So total resistance is 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now, if we include the values, say the voltage is 30 volts, resistances R1 is 6 ohms, R2 is 10 ohms, and R3 is 15 ohms, then now let's calculate the current at individual resistances. By Ohm's law, V is equal to IR. Let's convert the formula to calculate current, which becomes I is equal to V by R. And the current at resistance R1 is I1 is equal to V1 by R1. Voltage is same at anywhere in the circuit, so let's call V1 as V. So I1 is equal to V by R1, which becomes I is equal to 30 by 6, which is 5 amps. Current at resistance R2 is I2 is equal to V2 by R2. Again, voltage is same at anywhere in the circuit. So I2 is equal to V by R2, which is I2 is equal to 30 by 10. Then I2 is 3 amperes. And current at resistance R3 is I3 is equal to V3 by R3. Again, voltage is same everywhere in the circuit. So I3 is equal to V by R3. I3 is equal to 30 by 15, which is 2 amperes. Now, to get the total current, we need to sum up all the individual currents. So, I total is equal to I1 plus I2 plus I3, which is 5 plus 3 plus 2, which becomes 10 amperes. Then the total current in the circuit is 10 amperes. Now again let's calculate the current. but this time by using the total values. So I is equal to V by R. I total is equal to V total by R total. We already know voltage is same everywhere in parallel circuit. So we already have V total which is 30 volts, but we don't have the R total, so let's calculate the R total. We already have the formula to know the total resistance in parallel circuit, which is 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So 1 by R total is equal to 1 by 6 plus 1 by 10 plus 1 by 15. Then 1 by R total is equal to 0.113 by 1. To save some time, I am going to say it as 0.113, but you can clearly look at them in the screen. Now by cross multiplication, it becomes 0.113 R total is equal to 1 into 1, which is 0.113 R total is equal to 1. 0.113 go to the other side, which divides the 1. So R total is equal to 1 by 0.113. So R total is equal to 3.10 and 3, or R total is 3 ohms approximately. Now we also have the total resistance value. Also, notice that after calculating the total resistance, we got it as 3 ohms approximately, which is way less than the individual resistances, which are 6 ohms, 10 ohms, and 15 ohms, which means the overall resistance in parallel circuits reduce as the more number of components add up. Now let's get the total current. I total is equal to V total by R total, which is I total is equal to 30 by 3. So I total is equal to 10 amperes, which is same as when we calculated the current with the individual values. There can be more number of resistors or any other components can be connected if needed. The advantage of parallel circuit is even if one component is turned off or failed, then the rest of the circuit still functions. Also, the voltage is constant everywhere in the circuit. The disadvantage of parallel circuit is it requires complex wiring in design of circuit. The best example for parallel circuit is household electrical wiring. Even though if you turn on or turn off one switch, the other entire circuit still functions. To give some conclusion for parallel circuits, the voltage is same between 2 points at anywhere in the circuit, but the current is different at individual components. To remember the voltage is same and current is different, look at the word parallel. Unlike the word series, the word parallel has no letter I in it. By this, we can always remember voltage is same and current is different in parallel circuits. That's it for the video. Hope you got to know about series and parallel circuits. Don't forget to subscribe for future videos. Thank you for watching this video.